Very good morning. Today we'll see about analog communication systems. In this basic introduction to what is communication and about amplitude modulation, we'll see it. So communication is we know that the mode of transferring the information from one place to another place. So what is communication is being described by means of a block diagram. We have a information source. The information source can be of video signal or audio signal or a data. So this information has to be transferred to a long distance. So we have a transmitter next one, and we should communicate the data, the information whatever we have through the channel to the receiver. The channel can be of two types, that is wired communication or wireless communication. So based on the mode of communication we can fix the channel. So we have a receiver at the output side. So through the receiver the users can receive the information. So the process of conveying the message of information is called as communication. The transmitter modifies the message signal into a form which is suitable for the transmission over the channel, which is achieved by the modulation process. Because a low frequency signal cannot be transferred as such to a long distance. So before transferring that signal to a long distance, we need to communicate, we need to change the frequency to a very high value. The process is called as modulation process, and the device which is doing this, that is converting a low frequency signal for transmission to a long distance into a high frequency signal, is called as a modulator. So the modulation is basic requirement for transferring the message signal through the free space. It is the process of transmission of information signal, low frequency audio signal, using a high frequency carrier. If modulation is not done, then what happens? The carrying one signal to another, it uses a carrier having a high frequency, smaller wavelength. The modulated signal is being transmitted. The problems with the transmitting baseband signal is height of the receiving antenna. The antenna, whatever we fix it for receiving the information, it becomes very length, that is very height. If we are not doing it, if we are not converting that to a high frequency signal. And second one is the noise and interference from other sources at low frequencies multiplexing. That is low frequency noise signal will get overlapped with the low frequency information signal. And we have a narrow banding. So low frequency, if the information content want to transfer as such, then we need narrow banding process. Narrow banding is lower bandwidth requirement that is not being advisable for the long distance transmission. The practicability of the first point, we can discuss it by means of this. The height of the antenna, for example, if it is lambda by 4, that is wavelength, in terms of wavelength, if we are representing it for efficient transmission. For example, if the frequency is in the range of 30 Hertz, then the antenna height is being determined by lambda by 4. That becomes 2500 kilometer, which is not being practically possible. And if we go for the frequency slide from the hertz to kilohertz range, the antenna of the height becomes 25 kilometers. That is also not being possible practically. So if we are from the hertz to the megahertz range, if we are changing the frequency, then the antenna height becomes 25 meters alone, which can be implemented practically. So this is why the frequency transformation is done from the low frequency to the high frequency. So the next one is about modulation. That is defining this. So the need for modulation, we understand that the low frequency signal, if it is being as such, if it is being delivered, the practical length of the antenna becomes very high. And second one is the noise signal get overlapped with our information signal at a low frequency content. And third one is the narrow banding. And based on the need for modulation, we go for definition of the modulation. The definition of the modulation is, it is the process by which some characteristics of the signal that is amplitude or frequency called carrier is varied in accordance with the instantaneous value of another signal, which is called the modulating signal. So in short we can define it, that is we have the two signals. One is our information signal, and which is called as a modulating signal, and another one is the carrier signal, which is used to transfer our frequencies into a very high value. So this information content, the carrier signal which is used to carry our information, its parameters should be varied, such as its amplitude or frequency or phase should be varied in accordance with the original information content. This is called as the modulation process. The information bearing signal is called the modulating signal, and the signal which is resulting from the process of modulation is called as modulated signal. So we have two types of modulation, that is one is continuous wave modulation and another one is pulse modulation. So continuous wave modulation, again it is being divided into three types, that is if amplitude of the carrier is varied in accordance with the instantaneous signal, that is original baseband signal, it is called as amplitude modulation. If the frequency of the carrier is varied in accordance with the original information signal, that is called as frequency modulation. If phase of the original information signal is varied in accordance with the baseband signal, it is called as phase modulation. So pulse modulation is totally being different, where other than the sine wave as a carrier wave, we use the pulse signal as a carrier signal. So the types of modulation is sine wave carrier described by three parameters, that is amplitude, frequency and phase. Phase combined, the frequency and phase combined are known as angle modulation process. The amplitude modulation is being defined as the simply it is being defined as the carrier amplitude of the carrier is changed in accordance with the instantaneous value of the modulating signal. The instantaneous, we mean that instant time to time it has to show its variation. So that is with respect to the amplitude. So the carrier signal can be that is the modulating signal is represented as Vm into cos 2 pi Fm into t, where Vm is the signal's amplitude and Fm is the frequency of the carrier signal. And carrier signal, if it is represented as Vc into cos 2 pi Fc into t into plus pi, the carrier signal Vc is its amplitude and Fc is its frequency and pi is being the phase angle. Information is contained in the envelope. So you can after representing that by the equations, we can represent that by the diagram waveform like this. The first one is the modulating signal. It is having a low frequency content, so its time duration is, you can just note down the time duration. And amplitude modulated signal, you can note down the amplitude of the carrier signal. So carrier signal is for very high frequencies. So carrier signal having a very high frequencies, so its frequency, its amplitude is being varied in accordance with the modulating signal. So if we see the envelope of the amplitude modulated signal, we get the original information content. So the modulated signal can be represented like this. So carrier signal amplitude is going to be varied. So Vc into cos of 2 pi Fc into t into plus m into cos 2 pi Fm into t is your original signal, that is original baseband signal. So it has amplitude has to be varied. So Fc is the carrier frequency, Fm is the modulating frequency, and Vc is the unmodulated carrier amplitude. M is the modulation index. So one more parameter which is called as modulation index is being very important thing. The modulation index or degree of modulation. Its value must be between 0 and 1. If m is greater than 1, it is called as over modulation. If m is the best way, it must be between 0 to 1. If it is less than 0, it is called as under modulation. If it is greater than 1, it is called as bar modulation. It gets in results in distortions. It is called as over modulation. So you can just see the waveform by means of the modulation index. So original information content is first one, modulating signal. And second one is the unmodulated carrier, which is having the frequency high when compared with the modulating signal. Third one is the amplitude modulated waveform, where carrier amplitude is varied in accordance with the instantaneous value of the modulating signal. And the fourth one is the modulated carrier. If you are taking it for m equal to m value equal to 0.5 is first diagram. If m is exactly equal to 1, then you can just note down the variation in it. And it's in if m is greater than 1, some of the signal is being lost at nearly equal to 0, the signal is being lost. So it is called as over modulation. M value is being defined by the ratio of Vmax minus Vmin by Vmax plus Vmin, where Vmax is the maximum amplitude of the original signal Vm, that is baseband signal, that is modulated signal, and Vmin is the minimum amplitude found in the case of modulated signal, and that is being subtracted in the numerator, that is being added in the denominator. So if you see the sidebands that represent that in the frequency domain, you can just see the waveform where we have the carrier signal. Unmodulated carrier is the first one, and carrier is modulated with a sine wave, it getting the two components plus FM and minus FM components. Since its amplitude is being modulated, we have a carrier signal along with two sidebands. One is called as upper sideband and other one is called as lower sideband. The upper sideband usually represented as Fc plus FM, and lower sideband is represented as Fc minus FM. So that's about amplitude modulation process. It is a very important topic, beginning for the communication systems. Thank you all.